Okay, so it says if the function g of x is x squared plus 2 is a transformation of the parent function f of x is x squared, where is the y-intercept? Well, here's the thing. If it's outside the parentheses, right, that's a vertical shift. And that is going to go up 2. Right? But we got to know what the parent function is. So the parent function is x squared. So I'm going to double check this on my calculator. And they just want to know where it crosses the y-axis. So I'm going to take my calculator. I'm going to go and hit y equals. So the y equals button is right here. My parent function, and I'm just going to leave that in there because just about every problem we're going to do in this section will be compared to x squared, which is the parent function. It's the simplest version of a quadratic. And then I'm going to plug in x squared. So again, here's the x button. And then I'm going to hit the caret symbol. And then I'm going to hit 2. I'm going to hit the right cursor. And then I'm going to add 2. Then I'm going to hit the graph button. And then I'm going to graph the 2's. Now the blue one, it just goes through the origin, right? And the purple one just shifts up 2. So that's exactly what Mr. Adams said, right? It's just going to shift up 2 units. So let me take a picture of this and we'll zoom in on it. When I look at this graph, here's my parent function, f of x, which is equal to x squared, okay? And then the purple line is shifted up 2 units, right? So if you see here, it's shifted up 2 units, just like I said it would be. So that went up 2 units. And that is g of x, which is equal to x squared plus 2. And that plus 2 is the thing, but they want to know what is the y-intercept. So here's my y-axis. They want to know where this crosses at. Well, this point right here is the point 0, comma 2. So I think C would be the right answer. Okay. I'll leave that. Does anybody have any questions on that? So a lot of times, if you do enough of these problems, what will happen is you'll memorize the transformation, which is kind of cool. So I can almost graph. Of course, I'm a math teacher. I should be able to do this, but because I've practiced it a lot, I can look at an equation, and in my mind, I go, okay, the parent function crosses the origin. It looks like this blue graph. And then I go, okay, I'm going to slide it up. I'm going to stretch it. I'm going to move it down. I'm going to slide it to the left. And I can almost graph a function in my head. And that's very valuable because what I'm saying is in math, when is this math used in the real world? We collect data, and the behavior of the data will normally fit some type of mathematical equation. And then what we do is we transform the parent function to fit the data. That's what this stuff is really used